Good day, everyone. I'm teacher Justin, and for today, we're going to talk about finding the inverse of a function. So let's have our first example. So how do we find the inverse function of a of x is equal to 4x minus 5? So let's have our first step is for us to replace the function notation to y. So we will change it to y, and then we will proceed to swapping the variable x and y. So we will interchange x and y, then we will solve for the value of y. So we will isolate and place all the terms or numbers surrounding y to the other side of the equation, starting with adding both sides by 5. So we cancel this, and we will have x plus 5 is equal to 4y. Then we will remove the coefficient of y by dividing both sides by 4. So we can cancel that, and we will have y is equal to x plus 5 all over 4. Then after that, since y is already isolated, we will now replace it with the inverse notation. So we have the inverse of a of x is equal to x plus 5 all over 4. And that's it. Ta-da! All right. Okay, let's have another example. So for example, we are going to find the inverse of the given function b of x is equal to 2x plus 3. So first, we will start with replacing the function notation with y. So we will change b of x to y, and then we will swap x and y. So we will interchange or change y to x and then x to y. So we have x is equal to 2y plus 3. Then we solve for the value of y. So since y is already here in this right side of the equation, we will remove all the numbers surrounding y. So we start with subtracting both sides by 3. So we subtract both sides by 3, we cancel that, and we will have x minus 3 is equal to 2y. We remove the coefficient of y, which is 2, by dividing both sides by 2. So we cancel that, and that will give us y is equal to x minus 3 all over 2. Now, since y is already isolated, we can change the variable y to its inverse notation. So we have the inverse of b of x is equal to x minus 3 all over 2. And that's it. Ta-da! All right. Okay, let's have another item. Let's find the inverse function of c of x is equal to 1 over x plus 3. So first thing that we need to do here is for us to replace the function notation with y. So we change c of x with y. Then we will proceed to our second step, which is swap x and y. So we will interchange x and y. So we have x is equal to 1 over y plus 3. Then we proceed to the third step, which is to solve for y. So we need to isolate y in this side of the equation. Now, since y is in the denominator, we have to place the denominator y plus 3 to the numerator by multiplying both sides by y plus 3. Okay, so we can remove it from the denominator and place it beside x. So y plus 3 is equal to 1. Okay, so we have quantity y plus 3 times x is equal to 1. Now, instead of distributing x to y and 3, we will proceed to dividing both sides by x, because our main objective is for us to isolate the variable y. Then, we proceed to canceling the variable x, and we will end up with y plus 3 is equal to 1 over x. Then, we remove the constant 3 beside y, so we subtract both sides by 3, we cancel that, we will end up with y is equal to 1 over x minus 3. So now that y is isolated, we can replace y with the inverse notation, which is the inverse of c of x is equal to 1 over x minus 3. And that's it. Ta-da! All right. Okay, let's have another item. Let's find the inverse of d of x is equal to 2 all over x minus 2. So our first step is for us to replace the function notation with y. So we have y is equal to 2 all over x minus 2. Then we proceed to swapping x and y. So we have x is equal to 2 all over x minus 2. Our third step is for us to solve for y. So we isolate the variable y. So since it is in the denominator, we place it beside x by performing the multiplication property, multiplying both sides by y minus 2. Then we cancel this. We will end up with y minus 2 times x is equal to 2. So instead of applying the distributive property, since our objective is for us to isolate y, we will proceed to dividing both sides by x so that we can isolate the variable y. Divide both sides by x, we cancel x, and we end up with y minus 2 is equal to 2 over x. Then, we remove the constant term negative 2 by adding both sides by 2. So we have 2 over x plus 2. And since y is already isolated, we can change y to its inverse notation, which is the inverse of d of x is equal to 2 over x plus 2. And that's it. Ta-da! Alright. Okay, let's find the inverse of this given function. We have e of x is equal to the cube root of x plus 3. Okay, so the first thing that we need to do is for us to replace the function notation with y. So we will have y is equal to the cube root of x plus 3. Then we proceed to swapping x and y. So we interchange them. We have x is equal to the cube root of y plus 3. Then we solve for y. So we isolate the variable y by first removing the radical sign. So we get the inverse of the cube root symbol by getting the cube of both sides of the equation. So we cancel the exponent and the radical sign. So we will have x cubed is equal to y plus 3. Then we proceed to isolating the variable y by subtracting both sides by 3, removing the constant term. So we cancel 3. So we will have x cubed minus 3 is equal to y. Now, since y is already isolated, we can convert it to its inverse notation, which is the inverse of e of x is equal to x cubed minus 3. And that's it. Ta-da! Alright. Okay, let's have another item. Let's find the inverse of f of x is equal to the cube root of 2x plus 5 minus 1. So, first thing that we need to do here is for us to replace the function notation with y. So, we replace f of x with y, and we will now proceed to our second step, which is swap the x and y. So, we interchange x and y. So, x is equal to the cube root of 2y plus 5 minus 1. Now, we solve for the variable y. So, we isolate the variable y by removing all the terms, numbers, beside it. So we focus on the one outside our radical symbol, which is negative 1. So we remove negative 1 by adding both sides by 1. So we add both sides by 1. We have x plus 1 is equal to the cube root of 2y plus 5. Now we focus on the cube root symbol. We will be using the cube property, which is we get the cube of both sides. Okay, we can cancel the exponent and the radical sign, and giving us the cube of the sum of x and 1 is equal to 2y plus 5. Then we proceed to removing the constant 5. So we subtract both sides by 5. Okay, so that we can isolate the variable y, subtract both sides by 5, and then after that, we will proceed to dividing both sides by 2. And that will give us y is equal to the cube of the sum of x and 1 minus 5 all over 2. And since y is already isolated, we will change it with its inverse notation, which is the inverse of f of x. And that would be our final answer. Ta-da! Alright.